Question number 11. Magnetic energy stored in the inductor long time after the switch is closed. आपको याद है पिछले टेस्ट में हमने डिस्कस किया था the steady state of capacitor. In steady state, capacitor behaves as open circuit. Now, inductor in steady state behaves as short circuit. ये ध्यान देना, inductor behaves as short circuit, but कहाँ पर? At steady state. Now just see, if the inductor is replaced by a short wire, 20 volt divided by 5 ohm, the current will be 4 ampere at steady state. Now once you get the value of current, energy stored in the inductor निकालना कोई दिक्कत वाली बात है ही नहीं, because the formula for energy stored is half L multiplied by I square. So that means 16 joule will be the correct option. Now let's go to question number 12. Question number 12 क्या कहता है? A coaxial cable is made of two conductors. The inner conductor is solid and of radius R1. The outer conductor is hollow and of inner radius R2, outer radius R3. Space between the conductors is filled with air. The two conductors carry equal currents but in opposite direction. Variation of magnetic field with distance from the common axis. ठीक है, एक बार वो जो coaxial conductors है इनका top view बनाते हैं. If you see the top view, cross section आपको दिखेगा. So this is for the inner conductor जो कि solid है. The outer conductor, you know, it has two radii, so it would be something like this. Now just imagine ये रेडियस है R1, ये इनर रेडियस R2, ये आउटर रेडियस R3 और ध्यान देना करंट की जो डायरेक्शन है दैट इज अपोजिट. कायदे से मैग्नेटिक फील्ड निकालने के लिए you'll have to use the एम्पियर सर्किटल लॉ. एक परफेक्ट सिमेट्री केस है, एम्पियर सर्किटल लॉ का बेस्ट पॉसिबल सिनेरियो है. लेकिन इसको इस नजरिए से देखते हैं that if this question comes in your examination you have to solve it within 1 minute. तो सबसे पहली बात, आउटरमोस्ट जोन में द मैग्नेटिक फील्ड विल बी जीरो, क्योंकि जब आप करंट एनक्लोज निकालेंगे एक करंट पॉजिटिव अगला करंट नेगेटिव, करंट एनक्लोज विल बी जीरो. यानी कि R3 के बाद द मैग्नेटिक फील्ड हैज टू बी जीरो, जबकि ये R3 के बाद मैग्नेटिक फील्ड इज नॉन जीरो. सो ये ऑप्शन तो एलिमिनेट हो गया, ये भी एलिमिनेट हो गया, R3 के बाद मैग्नेटिक फील्ड नॉन जीरो. तो हमारे पास अब दो ऑप्शन बचे हैं, ऑप्शन नंबर 2 एंड ऑप्शन नंबर 3. नाउ से हाउ टू फिगर आउट दैट विच ऑप्शन इज करेक्ट. बड़े ध्यान से देखिए, फॉर एनी पॉइंट विच इज इनसाइड दिस सॉलिड कंडक्टर द मैग्नेटिक फील्ड इज डायरेक्टली प्रोपोर्शनल टू आर, द डिस्टेंस फ्रॉम द सेंटर. तो ऐसे सिचुएशन में फॉर डिस्टेंस बिटवीन 0 टू R1 सीधी सी बात है y इज डायरेक्टली प्रोपोर्शनल टू x. तो आपको मिलेगा इक्वेशन ऑफ स्ट्रेट लाइन पासिंग थ्रू द ओरिजिन. तो इस इंफॉर्मेशन के बेसिस से वी कैन एलिमिनेट ऑप्शन नंबर 2, बिकॉज ऑप्शन नंबर 2 सेज इनसाइड द इनर कंडक्टर द मैग्नेटिक फील्ड इज कांस्टेंट, जो कि है नहीं, एंड डायरेक्टली प्रोपोर्शनल टू x. ऑप्शन नंबर 3 गिव्स द करेक्ट वन. आप इस तरह से एलिमिनेशन की मदद से you can easily come up to the conclusion. That means option number 3 will be the correct one. You have to be a bit tricky. आपको बहुत सारे hacks apply करना होगा so that you would come to the accurate answer within record time. लेकिन solve करने के जल्दबाजी में you can't compromise on the accuracy. All right. Question number 13. Two charged particles A and B of same mass are accelerated through same potential difference. तो क्या क्या same है? Mass same है, potential difference same है. On entering a region of uniform magnetic field, both enter the same magnetic field, so even B is same. They describe circular paths of radii R1 and R2 respectively. हमें calculate करना है the ratio of charges of A and B. एक simple सी बात है. This question is related to motion of charge in magnetic field, specifically when it describes a circular trajectory. सर्कुलर ट्रैजेक्टरी के केस में रेडियस के अलग अलग एक्सप्रेशन हैं, हम वो एक्सप्रेशन चूज करेंगे व्हेन द चार्ज acquires the speed due to acceleration in an electric field, and that is 2qvm divided by bq. अब जरा ध्यान से देखना कि क्या क्या सेम है. 2 तो कांस्टेंट है, पोटेंशियल डिफरेंस दैट इज सेम, मास सेम, magnetic field is same. कहने का मतलब under this scenario the radius is inversely proportional to root q. I think now you got the way. Charges का ratio निकालना है, that means r2 by r1 will be equals to under root of q1 by q2, inversely proportional to square root है. निकालना था हमें q1 by q2, so that will be equals to r2 square upon r1 square. और ये ऑप्शन कहां पर है? That is present in option number 1. Okay, now moving to question number 14. What does it say? Two parallel long wires carrying current I1, I2 with I1 is greater than I2. जब दोनों में करंट सेम डायरेक्शन में है, the magnetic field at a point midway between the wires is 40 microtesla. और अगर डायरेक्शन ऑफ I1 को रिवर्स करते हैं, फील्ड बिकम्स 60 माइक्रोटेस्ला. विद दिस इंफॉर्मेशन आई गॉट टू कैलकुलेट द रेशियो ऑफ I1 इज टू I2. नाउ लेट्स सी फर्स्ट सिनेरियो, ये I1 मान लेते हैं, लॉन्ग वायर्स, हाफ आउट ऑफ द प्लेन, हाफ इनसाइड द प्लेन, सेम डायरेक्शन, so let's say this is I2. Now another thing that you have to understand is that midway पे निकालना है, so let me call this distance as x, so this will also be x. ध्यान से देखना, when the currents are in the same direction, इस given point पे magnetic field due to these individual current will be in the opposite direction. एक बार verify कर लेते हैं. I1 के कारण से field will be above and I2 के कारण से field will be below. क्योंकि I1 I2 से बड़ा है, so B1 will be larger than B2. So what would be the net field? Let me write. B net 1 will be mu naught I1 by 2 pi x minus mu naught I2 by 2 pi x. Well, in the next scenario, ये कहा गया है if the direction of I1 is reversed. अब अगर एक का डायरेक्शन रिवर्स हो जाए, the direction of magnetic field by both will be in the same direction. So that means the net magnetic field, now that is going to be something like this. Mu naught I1 by 2 pi x plus mu naught I2 by 2 pi x. I had to calculate the ratio of I1 is to I2, तो एक काम करते हैं, B net 1 or B net 2, let's divide them. If I divide them, the common factor gets cancelled, so this becomes I1 minus I2 by I1 plus of I2, or B1 by B2, that's simply 40 by 60, micro that gets cancelled out. 40 by 60 का मतलब that is equals to 2 by 3. Now, इस given expression से I1 upon I2 निकालना क्या कोई दिक्कत वाली बात है? I don't think so. Let me just show it to you. First, 3I1 minus 3I2, that is equals to 2I1 plus of 2I2. Cross multiply किया और कुछ नहीं किया है, okay? And this is I1 equals to 5I2. कहने का मतलब I1 upon I2 is 5 is to 1. बस search for the option of 5 is to 1 that is present in option number 3. Moving to question number 15, all right. There is this given charged particle of mass m charge q and it is projected into a transverse field. The range of the transverse field is 1.5 times r, which means r is the radius of the circular trajectory of this given path. हमें क्या निकालना? When it comes out of the field, what would be the deviation? That is what we have to find. Now straightforward, V is perpendicular to B, so the path will be circle. Circle या part of circle, but जो भी हो, it will fall either in a complete circle या part of circle. इसका जो center है, it will be somewhere here. Now you can easily see if I plot it, this is going to be something like this. ये जो given charge है, ये extreme edge तक पहुंच ही नहीं पाएगा because this is equals to the radius, all of you know, from the center till this given point, and this distance is larger than the radius. तो इससे हमें पता चला the path inside the magnetic field is a semicircle. Now when it comes out in this direction. तो साफ सी बात है फाइनल वेलोसिटी और इनिशियल वेलोसिटी के बीच में एंगल जो कि डेविएशन है दैट इज 180 डिग्री व्हिच मींस ऑप्शन नंबर 4. मूविंग टू क्वेश्चन नंबर 16. हमें मैग्नेटिक फील्ड निकालनी है required to accelerate proton, the mass is given, in a cyclotron that is operated at an oscillator frequency of 6 megahertz. Straightforward formula based question है. F equals to BQ divided by 2 pi m, जिसको हम कहते हैं cyclotron frequency. I had to calculate the magnetic field, so B is equals to 2 pi m F divided by Q. एक बात जो मैं constantly कहता आ रहा हूँ, the question that we give in the test series, ये question ऐसे नहीं होते कि आपको calculation में जाके उलझाया जाए, calculation में जाके फंसाया जाए. We make the question exactly in the format of need. Now, if you are thinking that this is going to be very troublesome in terms of calculation, excuse me, I'll just show you. Calculation are quite simple. कैसे? Let's see. ये है 2 pi. Mass is 1.67 into 10 raised to the power minus 27. The frequency is 6 megahertz. So 6 into 10 raised to the power 6 divided by प्रोटॉन है तो 1.6 into 10 raised to the power minus 19 कूलम है. अब देखो you just don't focus on the exact calculation. थोड़ा बहुत approximation लगाओ. Little bit of approximation will cancel this. इतनी बड़ी गुना नहीं है तो cancel 1.6 and 1.67 चल जाएगा. And this is going to be 10 raised to the power minus 27, 10 raised to the power minus 9. तो ये बनेगा 10 raised to the power minus 8. अब जरा ध्यान से देखो. This comes out to be 6 into 2 pi is 12 pi into 10 raised to the power minus of 2. Now say this is 0.12 into pi. Now just make a little bit of sense. ये आ जाता है 3.1415 multiplied by 0.12. काफी हद तक you get the sense that will be 0.4. यानी कि ऑप्शन नंबर 3. तो आपको ऐसी टेक्निक यूज करके you got to handle the calculation if at all it becomes a little bit tougher. Question number 17. चार्ज पार्टिकल का चार्ज दिया गया है, वेलोसिटी दी गई है. The magnetic field due to the charged particle at origin when the charged particle is at this. Okay, this is good. यानी कि charged particle is at 1,1. You got to calculate the magnetic field at origin and the charge is also moving with a certain velocity. आमतौर पे students do not pay attention to the expression of magnetic field due to moving charge, single charge. Current के कारण से तो वो याद करते हैं, but there is also an expression due to motion of single charge. And that expression is B vector is equals to mu naught by 4 pi Q V cross R vector divided by R cube. Now let's see. Well, mu naught by 4 pi, ये तो बन जाएगा 10 raised to the power minus 7. Charge की value 1 coulomb, needless to write. Velocity is 2I cap plus of J cap cross R vector. R vector will be in this direction. The beginning of R vector will always be the charge और उस point पे जाके end up होगा where you are supposed to calculate the magnetic field. तो R vector कैसे निकालें? Final coordinates minus initial coordinate. That means minus I cap minus of J cap divided by magnitude of R का cube. So magnitude of R is root 2 under root 1 square plus 1 square का cube. All right. Now let's see. This is equals to 10 raised to the power minus 7. Let's go for the cross product. I cross I 0. I cross j minus k यानी minus of 2k cap. इधर देखते हैं. j क्रॉस i हमें पता है वो है माइनस ऑफ k और माइनस है सो दैट इज प्लस ऑफ k एंड j क्रॉस j इज 0 और ये बन जाएगा, इसे ये तो लिख सकते हैं 2 raised to the power 3 by 2. We are done. 10 raised to the power minus 7 of minus k cap 2 raised to the power 3 by 2 in the denominator. साफ पता चल रहा है ऑप्शन नंबर 4. Now moving to question number 18. There is a charged particle which moves in this magnetic field and it has this much of acceleration. Value of x ये निकालना है. If you remember, the expression of the magnetic force is Q of V cross B. Now the property of cross product says कि ये जो force है magnetic field के साथ perpendicular होता है और force की जो direction है acceleration की भी वही direction है. That means acceleration is perpendicular to the magnetic field, which means acceleration dotted with magnetic field has to be equals to 0. Anyway, they are perpendicular. So let's do the dot product. और dot product तो दुनिया का सबसे आसान product है. Multiplication of respective I cap and j cap. So this is 3x plus of 8 that is equals to 0. In other words, x equals to minus of 8 divided by 3. Option number 1, that's the correct one. Well, moving to question number 19. The permanent magnetic moment of the atom of material is 0. सीधी सी बात है, fact based. This substance has to be diamagnetic क्योंकि paramagnetic और ferromagnetic में individual atom does possess a permanent magnetic dipole moment. Question number 20. Primary origin of magnetism lies in, because of the revolution of electron around the nucleus, यानी वो है atomic current and the intrinsic spin. इनके कारण से the magnetic property of a given material can be explained. So ये भी एक fact based question है. Option number 1, that's the correct one.